Good day, ma'am. Since we are done to linear equations, we now move to nonlinear equations, and we will going to talk about 2.1 quadratic equations and 2.2 revenue, cost, and profit, the sum parts of it, and presented by the group 5. And hello, classmates. We are the group 5, and I am Mary Joy A. Dinopol, and I am with Crystal Gale, Lawrence Dian, Riolin. And so, Joke is 2018. Nonlinear equations. The first section investigates the simplest nonlinear equation known as quadratic. A quadratic equation can easily be solved either by factorizing it as a product of two linear factors or by using a special formula. So what is 2.1 and 2.2? So in 2.1, we will going to talk about quadratic functions, as I said before, and some parts of 2.2, revenue, cost, and profit, because the group of Durama will continue that part. So our goals in this topic is solve a quadratic equation using the formula, solve a quadratic equation given its factorization, sketch the graph of quadratic function using a table of function values, sketch the graph of a quadratic function by finding the coordinates of the intercepts, solve the quadratic inequalities using a graph, solve inequalities using a sign diagrams, and the last goal is determine equilibrium price and quantity given by a pair of quadratic demand and supply functions. So Jacques 2018, quadratic equations is the simplest nonlinear equation. Nonlinear function is known as quadratic function, and it takes the form f of x equals ax squared plus bx plus c, where a is not equal to 0. So let's take a review. So the answer of x squared minus 9 equals 0 will be x is equal to 3 and x is negative 3. And also the answer of x squared minus 2 equals 0 will be x is equal to square root of 2 and x is equal to negative square root of 2. Now move on to the example. Solve the following quadratic equations. I hope you remember this topic when we were having summer class. So letter A is 5x squared minus 80 equals 0. Letter B is x squared plus 64 equals 0. Letter C is the quantity of x plus 4 squared equals 81. So this is the answer. So the answer of this is x is equal to 4 and x is negative 4. And answer to the letter B is no solution since we don't take imaginary numbers in this part. And to the letter C is will be equals to x is equal to 5 and x is equal to negative 13. So please see this PowerPoint presentation to take a review. So solve the following quadratic equations. Round your solution to the two decimal places. So these are the answers. Please see. As you can see that x is equal to 10 and x is equal to negative 10 of the answer of letter A. And this is the letter B, letter C, letter D, and also letter E, and letter F, and letter G. To solve more general quadratic equations, we use a formula that enables the solution to be calculated in a few lines of working. It can be shown that ax squared plus bx plus c is equal to 0, and x is equal to negative b plus minus square root of the quantity of b squared minus 4ac over 2a. So we all know what is this. This is the quadratic equation formula. So we all know how to solve this one by using the quadratic equations formula. So this is the example. 2x squared plus 9x plus 5 equals 0. B is x cubed minus 4x plus 4 equals 0. And 3x squared minus 5x plus 6 equals 0. So these are the answers. List C, and letter B, and letter C. If b squared minus 4ac is greater than to 0, then there are no solutions. X is equal to negative b plus square root of b squared minus 4ac equal over 2a, and x is equal to negative b minus square root of quantity of b x squared minus 4a. So that will be the two solutions. And if b squared minus 4a is equal to 0, then there are one solution, which is x is equal to negative b plus minus square root of 0 over 2a and equals to negative b over 2a. And if b squared minus 4ac is less than 0, then no solutions because of the square root. The quantity of b squared minus 4ac does not exist, just like how we answered a while ago.
Practice problem number 2. So let's solve for A. We have the given equation 2x squared minus 19x minus 10 is equals to 0. So our goal is to solve for x, and we're going to calculate the value of x that makes this equation true. Now we need to know what A, B, and C are equal to. So in the format where you have the x variables to the left and 0 on the right. So A is the number in front of x squared, while B is the number in front of x, and C is the constant term. So this is going to be A is equals to 2, b is equals to negative 19, and c is equals to negative 10. So in here, we need to solve with the quadratic formula. So the quadratic formula is negative b plus minus the square root of b squared minus 4ac divided by 2 times a. So we have negative 19 as our b plus minus the square root of negative 19 squared minus 4 and our a, which is 2, times negative 10, which is our c, divided by 2 times 2, which is our a. After that, negative 19 squared is equals to 361. And then negative 4 times 2 is equals to 8, and negative 8 times negative 10 is equals to 80. So 361 plus 80 is 441. So that the square root of 441 is 21. As shown in the screen, total is 21. So notice the plus and minus symbol. We need to break this up into two parts. So we're going to have to separate the solutions, where negative 19 plus 21 divided by 2 times 2, and negative 19 minus 21 divided by 2 times 2. So our first x is equals to 10, and our second x is equals to 1/2. So this is the answer to our problem letter A. So let us proceed with our problem B, where the given equation is 4x squared plus 12x plus 9 is equals to 0. So same with our problem A, we need to know what our A, B, and C are equal to. So our A is 4, B is 12, and our C is 9. So let us proceed with our quadratic formula, where negative 12 plus minus the square root of 12 squared minus 4 times 4, which is our A, and times 9, which is our B, divided by 2 times 4, which is our A. So after that, we need to solve this 12 squared first, where the answer is 144. Negative 4 times 9 is equals to negative 144. So our answer is 0. And so after that, x is equals to negative 12 divided by 2 times 4. So our answer is negative 3 squared. So that is the answer for our B. Another example is x squared plus x plus 1 is equals to 0. So let us solve it with the quadratic formula. So negative 1 plus minus the square root of negative 1 squared, which is our B, minus 4 times 1, which is our A, times 1, which is our C, divided by 2 times 1, which is our A. So negative 1 plus minus the square root of 1 minus 4. So 1 minus 4 is equals to 3. So x is equals to negative 1 plus minus the square root of 3 divided by 2 times 1. So after that, we need to separate our solutions. The first x is negative 1 plus square root of 3 divided by 2 times 1. And the answer is negative 1/2 plus I square root of 3 divided by 2. And the second x is negative 1 minus the square root of 3 divided by 2 times 1. And the answer is negative 1/2 minus I the square root of 3 divided by 2. So that is the answer for our C. So let us proceed with our D, where the given equation is x squared minus 3x plus 10 is equals to 2x plus 4. So we need to subtract 4 from both sides. So this will give us the x squared minus 3x plus 10 minus 4 is equals to 2x plus 4 minus 4. So we need to simplify it. So after that, this will give us x squared minus 3x plus 6 equals to 2x. And then after that, we need to subtract 2x from both sides. So x squared minus 3x plus 6 minus 2x is equals to 2x minus 2x. We will get x squared minus 5x plus 6 is equals to 0. So after that, we need to solve with the quadratic formula. So our A is 1, our B is 5, and our C is 6. So negative 5 plus minus the square root of our B, which is 5 squared, minus 4 times 1, which is our A, times 6, which is our C, divided by 2 times 1. 5 squared is equals to 25, and then negative 4 times 1 times 6 is equals to 24. So 25 minus 24 is 1. So we get negative 5 plus minus the square root of 1 divided by 2 times 1. So after that, we need to separate the solutions. So the first x is negative 5 plus the 1 divided by 2 times 1. So the answer is 3. And then the other one is negative 5 minus 1 divided by 2 times 1. So the answer is 2. So our 2x is 3 and 2. And that is the answer to our D. So a company sells packs of printer inks cartridges for $24. If a customer orders more than 100 packs, the company is prepared to reduce the unit price by 4 cents for each bought above 100 up to a maximum of 300 in a single order. So let us solve for A. How much does it cost to buy 130 packs? So the first 100 pack costs $24 each. So the total cost for this is 100 times 24 is equals to $24,000. The cost unit of the remaining 30 packs is 24 minus 0.04 times 30 is equals to $22.80. So the total cost of the extra 30 packs is 30 times 22.80 is equals to $684. So the cost of the complete order is $3,084. Let's proceed with letter B. So if the cost is $5,324, how many packs are ordered? So the total cost of packs bought in excess of 100 is $5,334 minus $2,400 is equals to $2,924. So 24 minus 0.04x giving a total cost of 24 minus 0.04x is equals to 24x minus 0.04x squared. Hence, 24x minus 0.04x squared is equals to 2,924, which rearranges as 0.04x squared minus 24x plus 2,924 is equals to 0. So this quadratic equation can be then solved using the formula. So let us use our quadratic formula. So x is equals to negative 24, which is our b, plus minus the square root of negative 24 squared, which is our b, minus 4 times 0.04, which is our a, times 2,924, which is our c, divided by 2 times 0.04, which is our a. So we will get 24 plus minus the square root of 576 minus 467.84 divided by 0.08. So 576 minus 467.84 is 108.16. So 24 plus minus the square root of 108.16 divided by 0.08 is equals to 24 plus minus 10.4 because that is the square root of 108.16 divided by 0.08. So given the two solutions where x is equals to 170 and x is equals to 430, the maximum permissible order is 300. So x is equals to 170, giving a total order of 100 plus 170 is equals to 270 packs of cartridges. So 270 packs of cartridges are ordered if the cost is $500,324.
So x plus 1 times x plus 2 equals x squared plus 3x plus 2. A b equals 0, a equals 0 or b equals 0. X minus 1 equals 0. So x equals 1. X plus 2 equals 0, so x equals negative 2. One important feature of linear function is that their graph are always straight lines. The intercept and slope vary from function to function, but the shape is always the same. Similar property holds for quadratic functions. Whenever you ask to produce a graph of an unfamiliar function, often a good idea to tabulate function, to plot these points on graph paper and to join them with smooth curves. The precise numbers of points to be taken depends on graph paper and to join them up with smooth curves. 5 and 10 points usually produce a good picture. So f of x equals x squared. So x equals negative 3, negative 2, negative 1, 0, 1, 2, and 3. So f of x is 9, 4, 1, 0, 1, 4, and 9. So negative 1 to 3 of x is incoming numbers. And 1 to 9 of f of x is outgoing numbers. Advice. Following problem is designed to give an opportunity to tabulate and sketch graphs of more general quadratic functions. So PIDMAS, P for brackets, I for increases, B for division, M for multiplication, A for addition, and S for subtraction. For example, A substitute x equals negative 1 into 4x squared minus 12x plus 5. So 4 times negative 1 squared minus 12 times negative 1 plus 5 equals 4 plus 12 plus 5. So equals negative 21. So practice problem. F of x equals 4x squared minus 12x plus 5. So x is negative 1, 0, 1, 2, and 3. And 1. F of x is 21, 5, 21, 13, 4, and 41. So the f of x equals negative x squared plus 6x minus 9. So x is 0, 1, 2, 3, 4, 5, 6. So f of x is negative 9, negative 2, negative 7, 18, 31, 46, and 63. So negative x squared plus 6x minus 9. So 4 squared plus 6 times 4 minus 9. So negative 2 plus 16 minus 6. So negative 2 is 4 squared plus 4 times 4 minus 6. So C, f of x equals negative 2 times negative 2 x squared plus 4x negative 6 minus 6. And x is negative 2, negative 1, 0, 1, 2, and 3, 4. F of x is negative 22, negative 12, negative 6, negative 4, negative 6, negative 12, and negative 10. Results practice problem 3 that graph of a quadratic is always parabolic. Figure 2.2, coefficients of x squared positive. So graph bends upward U or happy parabola, U shape. And figure 2.3, coefficients of x squared negative. So the graph bends downward or sad parabola, intended U shape. Task of sketching graphs from a table of function values is extremely tedious, particularly if only a rough sketch is required. It is usually more convenient just to determine a few key points on the curve. The obvious points is to find are the intercepts with coordinate axes. F of x equals ax squared plus bx plus c. So x is equal to 0. So f of x is 0 equals a 0 squared plus b 0 plus c equals c. So this is the graph. The constant term determines where is always parabolic. Figure 2.2, coefficients of x squared positive. So graph bends upward U or happy parabola, U shape. And figure 2.3, coefficients of x squared negative. So the graph bends downward or sad parabola, intended U shape. Task of sketching graphs from a table of function values is extremely tedious, particularly if only a rough sketch is required. It is usually more convenient just to determine a few key points on the curve. The obvious points is to find are the intercepts with coordinate axes. F of x equals ax squared plus bx plus c. So at x is equal to 0. So f of x is 0 equals a 0 squared plus b 0 plus c equals c. So this is the graph. The constant term determines where all the curve cuts to the vertical axis. The curve crosses the x-axis when y equals 0, when f of x equals 0. So we need to solve the quadratic equation. So ax squared plus bx plus c equals 0. Using the formula, and the solutions are the points where the graph cuts the horizontal axis. In general, a quadratic equation can have 2, 1, or no solutions. So A, the curve crosses the x-axis at A, turns around and crosses it again at B. So there are 2 solutions. So next is, the curve turns round just as it touches the x-axis. So there is only 1 solution. So the next is, the curve turns round before it has a chance to cross the axis.
So this is the continuation of our fourth goal to sketch the graph of a quadratic function by finding the coordinates of the intercept. So step 1, determine the basic shape. The graph has a U-shape or a smile face if A is greater than 0, and an inverted U-shape or a sad face shape if A is less than to 0. And step 2, determine the y-intercept. This is obtained by substituting x is 0 into the function, which gives y is c. Lastly, step 3, determine the x-intercepts. These are obtained by solving the quadratic equation ax squared plus bx plus c is equal to 0. So let's have an example. Fx equals negative x squared plus 8x minus 12. So step 1, the coefficient of x squared is negative 1, which is a negative, so the graph is a sad parabola or an inverted U shape. Step 2, the constant term is negative 12, so the graph crosses the vertical axis at y is equal to negative 12. So step 3, for the quadratic equation, negative x squared plus 8x minus 12 equal to 0. A is equal to negative 1, B is equal to 8, and C is equal to negative 12. So the formula gives x equal to negative 8 plus and minus divided 8 squared minus 4 times negative 1 times negative 2 over 2 times negative 1. So it is equal to negative 8 plus and minus divide 64 minus 48 over negative 2. So it is equal to negative 8 plus and minus divided 16 over negative 2 is equal to negative 8 plus and minus 4 over negative 2. So the graph crosses the horizontal axis at x is equal to negative 8 plus negative 4 minus negative 2 is equal to 2. And x is negative 8 minus 4 over negative 2 is equal to 6. So in the 3 steps, we obtain this graph by symmetry. The x-coordinate of this point occurs exactly halfway between x equal to 2 and x is equal to 6. That is, at x is 1/2 times 2 plus 6 is equal to 4. The corresponding y-coordinate is found by substituting x equal to 4 into the function to get f4 is equal to negative 4 squared plus 8 times 4 minus 12 equal to 4. The maximum point of the curve therefore has coordinates 4 and 4. So let's have another example. Fx is equal to 2x squared minus 11x minus 6. Step 1, 2x squared is equal to 2. It is a U shape or a happy face. So step 2, negative 6 constant term at y is equal to negative 6. Step 3, for the quadratic equation, 2x squared minus 11x minus 6. A is equal to 2, B is equal to negative 11, C is equal to negative 6. Equals 11 plus and minus divide negative 11 squared minus 4 times 2 times negative 6 over 2 times 2 is equal to 11 plus and minus divide 121 plus 48 over 4 is equal 11 plus and minus divide 169 over 4, and it is equal to 11 plus 13 over 4 is equal 6, and x is equal to 11 minus 13 over 4 is equal to negative 1/2. X is equal to 1/2 times 6 minus 1/2, so x is equal to 2.75, and f 2.75 equal to 2 times 2.75 squared minus 11 times 2.75 minus 6. So y is equal to negative 21.1.25. So this is the graph. Another example, fx equal to x squared minus 6x plus 9. So step 1, x squared is equal to 1, so it is a U shape. Step 2, 9 is equal to constant, so 0 and 9. Step 3, x squared minus 6x plus 9. A is equal to 1, B is equal to negative 6, and C is equal to 9. So 6 plus and minus divide negative 6 squared minus 4 times 1 times 9 over 2 times 9. So it is equal to 6 plus and minus divide 36 minus 36 over 2. So it is equal to 6 over 2, or B. So x is equal to 1/2 times 4, so x is equal to 2. F2 is equal to 2 squared minus 6 times 2 plus 9, so it is equal to negative 8 plus 9, so y is 1. So this is the graph. So let's solve the following quadratic inequalities. In letter A, negative x squared plus 8x minus negative 12 greater than 0, the quadratic function takes positive values when the graph is above the x-axis, so the inequality has the solution 2 less than x and less than 6. The values of 2 and 6 must be excluded from the solution since we required the quadratic to be strictly greater than 0. So in letter B, negative x squared plus 8x minus 12 less than or equal to 0, the graph is on or below the x-axis, the left of 2 and right of x, so the complete solution is x less than or equal to 2 and x is greater than or equal to 6. So let's have another example. So 2x squared minus 11x minus 6 less than or equal to 0. The quadratic function takes the negative positive values when the graph is above the x-axis. So the inequality has the solution negative 1 half less than or equal to x and less than or equal to 6. The values of negative 1 half and 6 must be included from the solution since we have required the quadratic to be strictly less than 0. So another problem, x squared minus 6x plus 9 greater than 0. The quadratic function is x less than 3 or x is greater than 3.
So our sixth goal is solve inequalities using sign diagram. So example, use a sign diagram to solve the following inequalities. Letter A, the quantity of x minus 2 and the quantity of x plus 3 greater than or equal to 0. So we know that the factor x minus 2 is at 0 will be equal to x equals 2. If x is lesser than 2, the factor is negative. For example, when x equals 1, the factor takes the value negative or less than negative 1 less than 0. When x is bigger than 2, the factor is positive. For example, when x is equal to 4, the factor takes the value 2 greater than to 0. These results illustrated in the number line. As you can see in this solution, the quantity of x minus 2 is we put 0 on the part of number 2. And uh, we put plus sign on the right side of number 2 and negative side on the left side of 2. So that's it. So just like what we did, we also put the following instruction on the quantity of x plus 3. So what we did is when x is at 0, we knew that x is equal to negative 3. So we put 0 on negative 3, and to the right side of the negative 3 will be positive, and to the left side will be negative. And if we combine, we just put first the 0 variable on the first variable that we have, or the first factor that we have. So we have x minus 2, and the 0 is on 2. And x plus 3 will be on the negative 3. So we just put first on that. We put 0 on those numbers. And that's the time we put positive sign on the left side of negative 3 and positive sign on the right side of 2. So that's the time we put negative sign on the middle of them. So next example. So this one. So this one is the factor of x plus 2 is 0 at x is equal to negative 2. Negative to the left of x equals minus 2. And positive to the right, the factors is obviously 0 at x is equal to 0. Negative to the left, x is equal to 0, and the positive to the right of this. The complete diagram is shown in the PowerPoint. So as you can see, we obtain first the variable x. So first we put 0 on the number line of 0. So the right side will be positive and to the left side will be negative. And to the quantity of x plus 2, we knew that if at 0, it is x equals negative 2. So we put 0 on negative 2, and to the right side is positive and to the left side is negative. And when we combine, we put first the variable x, which is 0. So first we put 0 on the 0 number line and the positive infinity on the negative 2. The rules for dividing negative numbers are the same as those for multiplying. So the diagram is completed in the same way as before. The only exception occurs at x is equal to negative 2 because we cannot divide by 0. This is indicated on the diagram by putting the symbol of infinity at this position on the line. The diagram shows that inequality x over x plus 2 is lesser than 0 is not satisfied. X is greater than negative 2 and x is less than 0. Now let's try practice problem. Use a sign diagram to solve the following inequalities. Letter A is the quantity of x minus 1 and the quantity of x minus 4 lesser than or equal to 0. So the first thing we did is, on the example that we have a while ago, so the first thing we did is if the x is at 0, we knew that x minus 1 will be equal to x is equal to 1. So we put 0 on the number line of 1 and positive to the right side and negative to the left side. And now, as well as to the x minus 4, when we know at 0, we knew that it is x equals 4. So we put 0 on 4. And now we have the answer here of the two quantity, which is the quantity of x minus 1, the quantity of x minus 4 will be here, as you can see in the PowerPoint. And it also satisfied that identify the interval will be x is greater than or equal to 1 and x is less than or equal to 4. So as you can see in the sign diagrams. So letter B, first we did is we get the first quantity. So this is a division. So the first quantity is x minus 1. So we knew that when x is at 0, we knew that x minus 1 will be equal to x equals 1. So we put 0 on number 1 number line. So the positive will be on the right side and the negative will be on the left side. So as well as the quantity of x plus 2, we knew that when x is at 0, it is x minus 2. So we put 0 on the negative number line and positive to the negative 2 and negative to the negative 2. So that's it. So we knew when we divide them two, first what we did is x minus 1, we knew that x minus 1 is we put 0 on the number 1 because that's what we got a while ago. So as you can see in the PowerPoint. But here in the negative 2, we put infinity because it is division and it is greater than or equal to 2. And it's satisfied that x is greater than x is less than negative 2 or x is greater than or equal to 1. So we knew that x is greater than or equal to 1. So we put equals. It only satisfies that when we put 0 is it satisfies that it has equals. And we put infinity here in the negative 2 because we knew that there's no equal. So we just put infinity. And the interval notation for that is negative infinity and negative 2. And to our seventh goal is determine equilibrium price and quantity given by a pair quadratic demand, supply, and functions. So now we have the example of the given supply and demand. P is equal to Q sub S squared plus 14Q sub S plus 22. And P is equal to negative QD squared minus 10QD plus 150. And we calculate the equilibrium price and the quantity. So how we can calculate equilibrium price and quantity here out. So here it is. Hence that Q squared plus 14Q plus 22 equals negative Q squared minus 10Q plus 150. Since both sides are equal to P, collecting the terms gives 2Q squared plus 24Q minus 128 equals 0, which is just a quadratic equation in the variable of Q. Before using the formula to solve this, it is a good idea to divide both sides by 2 to avoid large number. This gives us Q squared plus 12Q minus 64 equals 0. So we knew that we have letter A is equal to 1, and letter B is equal to 12, and letter C will be equal to negative 64. And we also knew a while ago what is quadratic equation formula. So those values of A and B and C, so we substitute there with the quadratic equation formula. And we get the answer of letter P, 4 squared plus 14, 14 the quantity of 4, and plus 22 equals 94. As checked, the demand equation gives us this negative the quantity of 4 squared minus negative 10 the quantity of 4 plus 150 equals 94. So where we get this one, the demand equation, what we did is we get the second P, which is negative Q squared minus 10Q plus 150. And now we have this. So now I calculate this one to get the point. So Q1 and Q2. So as I said a while ago, we get the second equation to get the points of Y. So the Q1 will be 54. I forgot to put here in the PowerPoint that the answer of our x here is negative 16 and 4. So we put here, we get the y-axis, we get the Q1. So the first x we have is negative 16. And the y for that is 54, as you can see the calculation here. And the second x is 4. So we got here the 94 y-axis. So this is the supply. As you can see, it is happy parabola. And then sad. Okay, so as you can see, that is the supply and the demand. The supply and demand curves are sketched in figure 2.5, which is in the PowerPoint. This shows that they are in the 2 points of intersections, confirming the mathematical solution. However, in economics, the quantity and price are both positive, so the functions are defined only in the top right hand, that is positive quadrant. In this region, there is 1 point intersection, 4 and 94. So that is our solution. So now move on to the practice problem. So we have the given supply and demand function, which is P is equal to 2QS squared plus 10Q sub S plus 10, and P equals negative Q sub D squared minus 5Q sub D plus 52. And then we calculate the equilibrium price and quantity. So as you can see in the PowerPoint, we already solved there since both sides are equal to P. And collecting like terms gives 3Q squared plus 15Q minus 42 equals 0. And the answer for that, we knew that letter A is equal to 3 and letter B is equal to 15 and negative 42 will be equal to letter C. So we just substitute those variables on the quadratic equation formula and we get the answer for X, which is 2, and Q, not another X, which is negative 7. So we knew that here in economics or here in business, we don't use negative. So as you can see in the next PowerPoint presentation here, our Y will be for 2, our Y will be 38 and another 38 for the negative 7. So we are talking here in the business, we don't get this one, this negative quadrant, but we are getting this positive quadrant. So that's how you determine the equilibrium price and the quantity given by a pair of quadratic demand supply functions. So that's it. So we have another example. Given the supply and demand function, P is equal to Q squared plus 2Q plus 12, and P is equal to negative Q squared minus 4Q plus 68. Solution. In equilibrium, Qs or Q sub S is equal to Q sub D, which is, if we denote equilibrium, the quantity by Q, the supply and demand function below. So P is equal to, so we excluded the S and D, and we just put Q. So we have here the Qs or the supply equals demand. So we have Q squared plus 2Q plus 12 equals negative Q squared minus 4Q plus 68. And we have the answer of 2Q squared plus 6Q minus 56 equals 0. And we will use quadratic formula. So we have the answer of Q, which is 4, and we have the answer of Q negative 7. Since we are in the business world, we don't use negative here. So we just use 4. And we have the graph here when what we use here is the demand equation, which is negative Q squared minus 4Q plus 68, and we substitute number 4 to it, and we got 36, and our supply is 4 and our demand is 36. As you can see in the graph, we just included the positive quadrant because that's what I've said a while ago, and basically this is the graph.
Next is the revenue, cost, and profit. So our goal here is sketch the graph of the total revenue, total cost, average, and the profit function. Second goal is find the level of output that maximize the total revenue. And our third goal is find the level of output that maximize profit. And our fourth goal is find the break-even levels of output. The main aim of this section is to investigate one particular function in economics, namely profit. By making reasonable simplifying assumption, the profit function is shown to be quadratic, and so the methods developed in section 2.1 can be used to analyze its properties. We describe how to find the levels of output required for a firm to break even and to maximize profit. So the profit function is denoted by pi and defined to be difference between total revenue. So TR and total cost TC, that is pi is equal to TR minus TC. This definition is entirely sensible because TR is amount of money received by the firm from the sale of its good, and TC is the amount of money that the firm has to spend to produce these goods. We begin by considering the total revenue and total cost function in turn. So the total revenue received from the sale of Q goods at price P is given by TR is equal to PQ. Let's have an example. The demand function P is equal to 100 minus TQ. So expresses TR as a function of Q and hence sketch its graph. We will answer the following question: for what values of Q is TR 0 and what is the maximum value of TR? So the total revenue is defined by TR is equal to PQ. And since P is equal to 100 minus 2Q, we have TR is equal to 100 minus 2Q times Q is equal to 100Q minus 2Q squared. So step 1, the coefficient of x squared is negative, so the graph has an inverted U shape. And step 2, the constant term is 0, so the graph crosses the TR axis at the origin. Lastly, to find where the curve crosses the horizontal axis, we would use the formula. However, this is not necessary since it follows immediately from the factorization. TR is equal to 100 minus 2Q times Q. So that TR is equal to 0 when either 100 minus 2Q equal to 0 or Q is equal to 0. So the answer in the first question, the total revenue is 0 when Q is equal to 0 and Q is equal to 50. Second question answered by symmetry, the parabola reaches its maximum halfway between 0 and 50, that is at Q is equal to 25. The corresponding total revenue is given by TR is equal to 100 times 25 minus 2 times 25 squared is equal to 1.
Practice problem. Number 1. Given the demand function P equals 1000 minus Q, express TR as a function of Q, and hence sketch a graph of TR against Q. What value of Q maximizes the total revenue, and what is the responding price? In general, the given linear demand function P equals A, Q plus B to the quantity of A lesser than 0 and B is greater than 0. The total revenue function is TR equals PQ equals the quantity of AQ plus B close and then Q and equals AQ squared plus BQ. This function is quadratic in Q, and since A is less than 0, the TR curve has inverted U. So sad. Moreover, since the constant term is 0, the curve always intersects the vertical axis as the origin. This fact should come as no surprise to you. If no goods are sold, the revenue must be 0. Now we turn our attention to the total cost function, or the TC, which relates the production cost to the level of output Q. As the quantity produced rises, the corresponding cost also rises, so the total cost function is increasing. However, in short run, some of these costs are fixed. Fixed costs, FC, include the cost of land, equipment, rent, possibly skilled labor. Obviously, in the long run, all costs variable, but these particular costs take time to vary, so they can thought of as peak in the short run. Variable costs, on the other hand, vary with output and include the cost of the raw materials, components, energy, and unskilled labor. If variable cost denotes VC, the variable cost per unit of output, then the total variable cost, TVC, in producing goods or Q is given by TVC equals the quantity of VC times Q. The total cost is the sum of the contributions from the fixed and variable cost, so is the given by total cost equals fixed cost plus the quantity of variable cost and goods. For example, suppose that an international car company operates 2 plants, one in the United States and one in Europe. And the total annual cost known to be 200 million and 45 million respectively. Which of these 2 plants regarding as the more efficient? Unfortunately, unless we also know the total number of cars produced, it is possible to make any judgment. The significant function here is not the total cost, but rather the average cost per car. If the US and European plants manufacture 80,000 and 15,000 cars, respectively, their corresponding average cost is equal to 200 million over divide 80,000 will be equals to 200. Here it is, 2,500. And the other one is 45 million over 15,000 will be equals to 3,000. One of the bases of these figures, the US plan appears to be more efficient. In practice, other factors would be taken into account before deciding to increase or decrease the scale of operation in either country. In general, the average cost function, or the AC, is obtained by dividing the cost by output, so that AC, or the average cost, is total cost over goods is equal to fixed cost plus the quantity of variable cost times Q. We divide by Q, or the goods, so the fixed cost over goods plus VC, which is the variable cost, cancel out because of the divide of also of the goods, and we have AC here, which is FC, fixed cost over goods plus variable cost. If the fixed cost equals 1,000 and the variable cost per unit equals 4, then the expression for the total average cost functions are 100 plus 4Q, and our AC here is TC over goods, total cost over goods. So we have 1,000 plus 4Q over Q. So we have 1,000 over Q plus 4. So this is how we get it, as you can see in the video. Yes. So the AC here is, so as you can see, we already did how we input those variables. So now, as you can see, the graph of the average cost function based on the table is sketched on figure 2.8. This curve is known as rectangular hyperbola and is sometimes referred to by the economists as being L-shaped. As you can see in the figure, the second figure, okay? Figure 2.8. So that's it. Thank you so much. Thank you so much, classmates, for listening to our report. And we are the group 5. We reported about 2.1 and some part of 2.2, and the group of normal will continue the part of 2.2. Thank you so much for listening. Bye.